This video is about solving logarithmic and exponential equations. The first one, we have log base 6 of 3x equals log base 6 of 5x minus 8. It's important to understand that if I have two log functions that have the same base and they're equal to each other, then the insides have to be equal to each other. That just makes sense. For example, if I had log base 7 of 12, it would have to equal log base 7 of 12. It couldn't equal log base 7 of 13 or anything else. So therefore, since that's the case, 3x must equal 5x minus 8. And so then we can solve this and get 2x equals 8 and x equals 4. It's very important to just make sure that your x value will make these work. So if I plug x in, I did end up getting 12. So log base 6 of 12 equals log base 6 of 12. Why is that important? Well, let's say I have an equation like log base 5 of 2x minus 3 equals log base 5 of 4x plus 7. If I have something like this, then I would set the two things equal to each other. So 2x minus 3 equals 4x plus 7. I get 2x equals negative 10, and x equals negative 5. If I substitute negative 5 in, I would get log base 5 of negative 13. And the problem with that is I can't substitute negative numbers on the inside of logs. Now, I can substitute a negative x value, but I can't have the entire inside be negative. So this would actually have no solution because negative 5 doesn't actually make it work. So that's something that's kind of important for our understanding of these problems. Number 2, natural log of the square root of x plus 2 is equal to 1. So we're going to use some properties of logs. In this case, the square root, this is actually a property of square roots. So x plus 2 would then be taken to the 1/2 power. So the square root is the same thing as the 1/2 power. And then a property of logarithms is that we can take exponents, move them to the front, and turn them into multipliers. So 1/2 times the natural log of x plus 2 equals 1. Then I can multiply both sides by 2, so the natural log of x plus 2 equals 2. And now I can eliminate the log by taking the inverse function of it. And remember, inverse function of natural log is e to a power. So I'll take e to both sides. So I will have e to the natural log of x plus 2. That undoes the natural log. So I'll have x plus 2 equals e squared. So x equals e squared minus 2. If I substituted that in, I would end up getting e squared minus 2 plus 2, which is the natural log of the square root of e squared, which is the natural log of e, which is 1. So it does end up working out. Number 3, I'm going to use some properties of logs. A property of logs that we're going to talk about is condensing. So if I have this plus sign here, what I can do is I can condense these logs to be log base 3 of x times x squared minus 8. And that equals log base 3 of 8x. So now log base 3 of x cubed minus 8x equals log base 3 of 8x. Therefore, I can set the interiors equal to each other because they're all log base 3. So I have x cubed minus 8x equals 8x. I'll subtract 8x over to the other side, so x cubed minus 16x equals 0. Then I would factor out the greatest common factor, x. So I have x times x squared minus 16 equals 0. Then I can further factor this to x times x minus 4 times x plus 4. So x can equal 0, x equals 4, and x equals negative 4 are my three potential answers. Notice I say potential because if I substitute in 0, I would get log base 3 of 0 plus log base 3 of negative 8, neither of which is the thing, right? So because both of those are not even possible, I would have to eliminate that as a potential option. Also, if I substitute in negative 4, notice that both log base 3 of x and log base 3 of 8x would end up being negative, and we can't have negative numbers on the inside of logs. But x equals 4 is a potential solution. Log base 3 of 4 plus log base 3 of 8 is in fact log base 3 of 8 times 4, which is 32, because I can use condensing rules to see that log base 3 of 4 times 8 would be log base 3 of 32. So x equals 4 would be the only answer to this, even though I got 3 originally. So make sure you check for extraneous solutions. Those don't work. In problem 4, I have 2 log base 3s, but I can't really do anything with them right now because they have coefficients. So in this problem, I can do basically the reverse of what I did in problem 2. And I can take those coefficients and turn them into exponents. So I have log base 3 of x to the 1/2 equals log base 3 of 4. And it's 4 because I moved that 2 to be an exponent. So it's the same as 2 squared, right? So now I have log base 3 on both sides. So because of that, the insides are the same. So x to the 1/2 equals 4. And I square both sides. So x equals 16. And so 1/2 times log base 3 of 16 would equal 2 times log base 3 of 2. Number 5, notice that these do not have the same base. So since they don't have the same base, that's a little bit problematic, right? So I can use the change of base formula in order to simplify that. But I could also just recognize that log base 3 of 27 is simplifiable. So log base 3 of 27 is the same as log base 3 of 3 to the third. So that means this is 3. So 3 equals log base 4 of x squared minus 1. And so now in order to eliminate the log and be able to solve this, I would take 4 to both sides. So 4 to the third power is 64. And 4 to the log base 4 basically ends up going away. So I have x squared minus 1 equals 64. So x squared equals 65. And x equals plus or minus the square root of 65. And in this case, both of them would end up working out because negative square root of 65 squared gives me a positive number. So is it true that log base 3 of 27 is equal to log base 4 of 65 minus 1? Yes, because log base 4 of 64 is going to end up giving me 3, just like log base 3 of 27 does. Number 6, log base 9 is what we have going on here. And so what I can do, again, is I can condense this. I can take the coefficient and turn it into an exponent. So log base 9 of the square root of x squared is the same thing as log base 9 of x. And then I have minus log base 9 of 6x minus 1. And so since I have a minus sign, I can condense those with division. So x over 6x minus 1. And that's equal to 0. And so now what I can do is I can eliminate the log by taking 9 to both sides. So 9 to the 0 is 1. And then 9 to the log base 9 of the inside is just whatever's on the inside. So now I have x over 6x minus 1 equals 1. I cross multiply and I get x equals 6x minus 1. So I get negative 5x equals negative 1 and x equals 1/5. So if I look at these situations, both of these are going to end up being positive numbers on the inside of the log. Square root of 1/5 is small, but it's positive. And 6/5 minus 1 is also small, but it's also positive, right? So it ends up working out pretty well. Let's talk a little bit about exponentials. So if I have problem 7 here, 2 to the 4x minus 5 equals 8 to the x plus 3. What I can do is I can rewrite this 8 as a power of 2, so it's 2 cubed. So then I have 4x minus 5 equals 3x plus 9, so x equals 14 is my answer. And I don't really have to check too much to see whether there are extraneous solutions in exponential problems, because the domain of exponentials is negative infinity to infinity. Now in this problem, I have the same everything except this 8 turns into a 9. So that ends up being an issue. So now what I would do is I would choose some log to take of both sides. You can either choose log base 2 or log base 9, but you have to do the same thing to both sides. So now what happens is log base 2 of 2, they end up canceling out with each other. So now I have 4x minus 5. And remember, if I have an exponent, I can move that to the front. I can move that to be a coefficient of log base 2 of 9 in this case. So now what I would want to do is I would want to distribute. This problem actually takes a while. So now I have 4x minus 5 equals x times log base 2 of 9 plus 3 times log base 2 of 9. Now, in order to get x by itself, I'm going to have to factor x out. So I have to subtract everything dealing with x over to one side, move everything dealing with x to one side, and move everything that doesn't deal with x to the other side. And then I can factor out the x. So I have 4 minus log base 2 of 9 times x equals 3 log base 2 of 9 plus 5. And then my final answer, I need to make a little more room for myself. My final answer is going to be x equals 3 log base 2 of 9 plus 5 over 4 minus log base 2 of 9. So that's my final answer there. If I chose log base 9 of 2, my answer would look different, but it would be equivalent if I did the same process. Number 9, e to the 6x plus 7 equals 14. How I get rid of e is I take a natural log of both sides. So I have natural log of e to the 6x plus 7 equals the natural log of 14. Notice that natural log of e to the 6x plus 7 is just going to be 6x plus 7. Now I solve for x by subtracting 7 and dividing by 6. So x equals natural log of 14 minus 7. I tend to write it as negative 7 plus natural log of 14, so there's no confusion. You also could put the 14 in parentheses to avoid any confusion too, and then divided by 6. Finally, number 10. If I have e to the 2x plus e to the x, what I might want to do is subtract 6 from both sides. And then notice that this looks a whole lot like a squared plus a minus 6. This looks very similar, so I can actually factor this. So I would factor this to be e to the x plus 3 times e to the x minus 2. So notice I can set both parts equal to 0, so e to the x equals negative 3, and e to the x equals 2. This one doesn't make any sense. An exponential function can never equal a negative number if it's a positive exponential function. So that one doesn't make any sense. But this one, I can then take log of both sides, so x equals the natural log of 2, and that would be the only answer that works in this case.